And if you don't want to be heard on camera, then don't say anything. Okay? Camera's right there. It's the only thing the board and me. So, okay, so let's look at lecture 14. Once again, the first 13 we're just kind of skipping through. We will do that throughout the year. Skip some that we'll even get to the majority of what I want to hit this year. So the first one is what we're going to talk about is functions. I know we talked about it a little bit in Algebra 2, so hopefully we're going to review a little bit of that. Well, let's look at functions. Number one, and this is kind of like a introductory point. The question is, what is a function? And I'm going to abbreviate function f of x. That's function notation, if you remember that. It means the function in terms of x. That does not mean f times x. That means the function of f with respect or in relationship to x. So, what is a function? Can anyone define it for me? Definition of a function. Not a party. Take a guess. Wild guess. First day math class, take a guess. What is a function? What do you think? Yeah?
An algebraic equation.
It can be an equation, can also be an expression, but yeah, it definitely can be that. Definitely some sort of rule, right? Okay. Anybody else? A function? Last year in Algebra 2 we talked about how to decide if it's a function or not. No? All right. So a function is a rule or expression. By the way, you will want to take notes. I would abbreviate as much as you can. I'm not going to abbreviate too much on the board, but abbreviate because you need to make sure it's understandable for you. And you can use notes on quizzes. So you'll read that in the syllabus. The fact that homework is I'll help you with that, do whatever I can to help. Quizzes, I'm not going to help you, but you'll have your notes and homework to help you. And then when we come to a test or an exam, nothing, just you and your brain, okay? So you might want to write this stuff down. Once again, notate as much as you can. You don't want to write down every word. But then something you understand so you can use it in the quiz. So it's a rule or expression that, and there's lots of words we could put here. It relates or it maps. Relates or it maps one value. Now in here I'm going to just find one value. One value, lots of times we use the letter x. Doesn't have to be an x, so it can be any variable, right? Or what we call this back in elementary, an independent variable. Okay. What did we call this last year in Algebra 2? The value that goes in for x. Starts with a D. Domain. It takes one value, we call that the domain, the x value, the independent variable, okay? It relates, the expression that relates one value to another. And then of course that we call going to be the y or the dependent variable, okay? Does anyone know what the word we put on that one?
Range.
Range. Now range is a more specific term. The actual term is called the codomain. We have the domain and the codomain. The range is a very specific type of codomain. Okay? And we're just going to call it the range this year. Okay? But when you get to upper level, you'll learn a more precise definition. Okay? So a rule or expression that relates or maps one value, the x value, to another, the y. Okay? So that's a function. Questions? We got that? You remember that definition now? Okay. Okay, so then, another dash. What is a one-to-one function? What is a one-to-one function? Specific type of function. Yeah?
Something that has equal input and output.
Has equal input and output?
That has the same input and output. Like x and y are equal to 1.
No. Appreciate your guess though. Appreciate you trying. Anybody else? One-to-one function. Yeah.
One independent variable, one dependent.
Talk to me more about that.
That's all I got.
Just one independent and one.
Yeah.
No. You watch basketball, right? There's a thing called man-to-man defense, right? What's man-to-man defense?
One player guarding another.
So one person's guarding another, right? And if both teams are playing man-to-man defense, if I'm guarding you, a lot of times you guard me, right? Did you ever play, did anyone here ever play upward basketball? It's like a league, so don't play upward. So in upward basketball, they try to do things even. They want to make sure it's a fair game, right? So you have 5 wristbands, okay? And you give every player on your team a set of wristbands. They're all different colors. Red, blue, green, yellow. Oh, something like that. I don't remember, it's been years. Okay, and the other team does the same thing, and you put like red on your best player, and you put blue on your second best, and then the worst player of the 5, you put whatever color, okay? So when you get on the court, the other team has done the same thing, so you have your best player defending their best player. You have your worst player on the court defending their worst player on the court, so it's all kind of fair, right? Especially when you're talking about like 5, 6, 7, 8-year-olds, okay? Height doesn't really matter, point guard doesn't really matter. It's all herd ball anyway, right? So it's one-to-one, okay? It's this person guards this person and they guard them back. Same thing with the one-to-one function, okay? It maps or relates 1x to 1y and that same y back to x. X goes to y and y goes to x. Let's give an example, a non-mathematical one. Jade, when's your birthday?
September 9th.
September 9th, you got one coming up. My dad's is September 8th, happy birthday. So September 9th. Notice she didn't say it's September 9th and March 4th. Okay, she gave one date, right? That's a function. Okay, that's a function. So you've got one birthday. It takes one value relates you to, well, you're the independent variable, to one dependent, to one birthday. Now, if I were to say, I want you to guess somebody who has a birthday on September 9th. Is there only one person who has a birthday on September 9th? No, there's many people, right? Lots of people have birthdays on September 9th. Millions of people. It's not one-to-one. September 9th doesn't belong to you. Even if I ask for the year, that day doesn't specifically map to you. I went to high school with a kid who was born, I didn't meet him until we were in high school, 9th grade. He was in my class, he was born the exact same day, exact same time, same hospital. We were actually born like 10 minutes apart, the exact same hospital. Okay, doesn't belong to me, it's not one-to-one. So one-to-one means if X belongs to Y, then Y also belongs to X. Okay, there's only a one-to-one correlation. Okay, so let's do this visually. I hope I've said enough to where now you can remember what's the test? To test to see if something is a function. Vertical line test. Very good. Vertical line test. So if I give you a function, oh, I don't know, maybe some sort of polynomial like that. Anywhere I go on that function, doesn't matter where it's at, it's only going to touch the function once. So it is a function. Okay? How do I test to see if it's one-to-one? What's the test to see if it's a one-to-one function? Yes?
If it touches 2 times.
No. If it touches 2 times, it's not even a function. Okay? So for instance, if I have a circle, it touches it twice, it's not even a function. It's not even going to be part of our conversation. We actually just call that a relation. Okay? So what would be the test for one-to-one function? Huh?
A horizontal line test.
Horizontal line test. Outstanding. So if I have a parabola that absolutely 100% passes the vertical line test, does it pass the horizontal line test? No, it touches it 2 places. It touches it here and here. So it's not one-to-one. Okay, then so what would be a function that is one-to-one? Can you think of an example?
Linear.
Linear, all linear or one-to-one. I saw it earlier, I was like, I wonder if that one. So what's the example besides linear? What's an example besides linear? Anything that passes the vertical line. Talked about all these functions last year.
Quadratic.
Quadratic, that would be a parabola. That is not.
Absolute value.
Absolute value is a V. Absolute value looks like, oops. Absolute value looks like that, not one-to-one. So we've got the U and the V, those are not. We have linear. Anything another? Algebra 2 people, we talked about this for like 3 months last year. Exponential. Thank you so much. You've given me hope. Exponential. So an exponential function looks something like that. Absolutely 100% one-to-one function. So we have linear, we have exponential, we have cubic function, we have square root function. All right. Questions on functions and one-to-one, are we good? Is it all coming back to us? Remember all that? Yep, okay. Very good. Third one. This is still part of the introduction. That's scary. Okay, basic transformations. Okay, so basic transformations. What happens if I take a function like, let's say, f of x, some function, and then I add a number to it, like add 3. I just take any function, take quadratic, and add 3 to it. What does it do to the function? Yeah.
Doesn't it go up
Here's it.
on the area? I always forget what it's called. The axis.
The Y?
All you have to do is say is move it, moves it up. Yeah, it moves it up. It goes up. By 3. We're just looking where it goes. You don't need to say anything else. Because it's not always on the axis. Sometimes it's off in the middle of the quadrant. So it just moves it up. Just slides it up. Okay. So what about if I subtract some number? What's that going to do? Goes down. And it doesn't matter what the function is. Doesn't matter if it's quadratic or cubic or polynomial, or as we'll talk about this year, doesn't matter if it's sine or cosine, okay, or tangent. Those curves also just move up or down. That's all it does. Same transformation. How do I get it to move left or right?
Multiply.
Parentheses?
Divide.
Multiply and divide actually stretch them or shrink them. What'd you say?
Parentheses?
What do you mean parentheses?
Huh?
What do you mean parentheses?
Put the number in the parentheses.
Outstanding. So like f of x plus 2. Okay. Now I put the number inside with the x, right?
Yeah.
Okay. Now, which way is it going to move it? Be careful. It's in with the x. So which way is it going to move it?
Right.
It's going to go the opposite of what you think, or it's not what you expect. So it's going to go left 2. Okay. And then if f of x minus 4, that's going to move it to the right 40 degrees. It doesn't matter what the function is, doesn't matter what type it is, that's how they move. Okay, come back with your answer here just a second, all right? Okay. How do I get to flip the function? By what?
Half.
We'll multiply by what? Like, for instance, I have a parabola, but I want it to look like that. What do I multiply by?
-1.
Negative. So if I do negative f of x, I put the negative out front, I multiply everything by -1. Okay, that's going to reflect, or flip it, if you will. All right, those will come back to be important later on. You good so far? Is all this review? Can I pick up the pace a little faster? Yeah, can I go a little faster or? Yeah, okay, here we go. Room number 1. This would be the first, all that was review, room number 1. Okay, so domain. Now you all said earlier the domain is the X, it's the independent variable, it's all the possible values for, and I'm just going to use X, but it's really our independent variable. It's all the possible values for X. Okay? So for instance, when you go to the gas station and fill up your car with gas, okay? Can I put in, can X equal 19.321 gallons? Can I put in 19.321 gallons?
Yes.
Absolutely. That's perfectly fine. Okay. If I had a semi truck, I could put in 120.324 gallons, right? When you play basketball, can you make a shot that's worth 19.321 points?
No.
Excuse me? You sure?
Yeah.
Yeah, in basketball it doesn't work. How about in basketball, can I shoot something and make 2.4 points?
No.
What?
Because it's not like a set number. You can have a decimal in basketball.
You can't have a decimal in basketball?
Right.
What type of numbers do I have in basketball?
Whole numbers.
Whole numbers, okay, yes.
I thought the.
Okay, so yeah, it has to be a positive integer. I can't have negative integers. Can I have a golf score of -2? You guys know anything about golf?
Yes.
Yeah.
Yeah, you can. 2 below par, right? You can't have negative. Can I have a golf score of 2.2? Well, no, because it has to be integers, positive or negative. Okay, so the domain of my situation defines what numbers I can put in. Okay, silly example, and it goes back years. You can't go to the store and buy 2.5 eggs. You can buy 2.5 dozen eggs, but you can't buy 2.5 eggs because you can't buy half of something. So we have to look at, okay, the domain is all the possible values that can go in for X. In basketball, with one release of the basket, with one shot, you can either score 0, 1, 2, 3 points. Okay, you can't score 4 points. There's no 5-point play. Okay, in football, you can only score 0, 1, 2, 3, 6. Yeah, that's it, right?
Yeah.
0, 1, 2, 3, 6. Yeah. All right. So what goes into is by definition the domain. Okay. Now it's our job in math to figure out what is the domain. So number 1, or Roman numeral A, we're going to look at a couple different specific types of functions. Number 1, a polynomial. This is actually a test question. I will simply say find the domain of these functions. First one is going to be a polynomial. Now, if you're in a polynomial is going to have basically one variable like an x, and I'm going to have a power of 2, a 3, 4. It's not going to be divided by anything. It's not going to be a radical. It's going to look something like f of x is going to equal, let's use the one in my notes, x squared minus 7x. X squared minus 7x. Is there any limit to what I can put in there? Is there any limit to what number I can square something and multiply it by 7?
No.
There's no limit. I can do it to whole numbers. I can do it to integers. I can square an integer. Can I square decimals?
Yeah.
Can I square fractions?
Yeah.
Can I square irrational numbers? Like, can I take the square root of 4, whoops, that's bad. The square root of 2 squared. Can I do that?
Yeah.
Absolutely. Okay? So when it comes to polynomials, whenever you see a polynomial, the domain is going to be negative infinity to infinity, everything. Anything on a number line. And normally we notate that with the funky looking R, if you remember the R from last year. All reals. You can use the funky looking R for that. So it doesn't matter what the polynomial is, doesn't matter what the power is, doesn't matter if it's 3rd degree, 5th degree, 10th degree. If it's a polynomial, the answer will always be all reals. Okay? Number 2. letter B. Rational. Rational functions. So a rational function, I wish they would teach this in 5th grade when they teach fractions, because a rational is simply a fraction, right? So rational function, we have 3x plus 2 divided by x squared minus 2x minus 3. Can I put any value I want in here for x?
No.
What's the issue with rationals?
Because if x is the one thing, it has to equal every x.
It has to equal every x, but what would be the problem with this? What would the no-no be? What can you not do? Yeah.
Can you not, isn't it that you can't have the squared x because x has to be one thing?
No, you can square x. Yeah, I can square any number. What's my limitation on that denominator? What can that denominator not be? Because you cannot do this. You can never divide by 0. Thou shalt not divide by 0. 11th commandment. Okay? So, x squared minus 2x minus 3 cannot be 0. So that's my limitation. X squared minus 2x minus 3 cannot be equal to 0. Any other number works except for the values that makes that denominator 0. Okay? So we have our quadratic. So let's go ahead and solve our quadratic. Remember, you can factor, you can use quadratic formula, I don't care. I'm going to go with x minus 3 times x plus 1 cannot be equal to 0. Solve our quadratic. Okay? So x cannot be 3. X cannot be negative 1. Because if x is 3, look what happens. If I plug in 3 to the bottom, it doesn't matter what the top is. If I plug in 3, it's going to be 11. If I plug in 3 down here, I'm going to get 9 minus 6 minus 3, which gives me 11 over 0. And that's a no-no. That's a problem. Okay? So then, my domain is, once again, all reals. X cannot be 3 or negative 1. So whatever the denominator is, it cannot be 0. Solve, and that's your domain restriction. That's your no-nos. That's your. We're going to learn later. That's our vertical. If you remember from last year, it's our vertical asymptotes. Remember that from last year? Vertical asymptotes.
Remember the word.
Remember the word. Okay, that's going to be our issue. That's going to be our problem areas. Does that make sense? We good? So polynomials, all reals. Rationals, where the domain has a problem, is where the denominator is 0. Okay, number 3. Oh, we're on a couple of those here. Square root, or we could call it radical function. In this class, we probably won't go to more radicals other than square root, but we could also do cube roots and fourth roots as well. We'll probably just stick with square roots. So something like the square root of, and let's go with 3x plus 12. And that's going to be our, I put h of x, doesn't matter what letter we use. That's my function. Okay, so with rationals, we talked about how the denominator can't be 0. What's my limitation on radicals? Especially square roots. What cannot be underneath that radical? Yeah?
Isn't it anything greater than 1?
No, you can have the square root of 1, square root of 2, square root of 3, square root of 4. Can I do fractions?
Yes.
I can do the square, you can grab a calculator. I can do the square root of 1/2. I can do the square root of 1/7. Yes?
Decimals?
I can do the square root of 0.25 is 0.5. So I can do the square root of decimals. Decimals are fractions of the same. What can I not take the radical of? It's not allowed. In fact, some might call it imaginary.
Negative 1.
Negative. Can't have negative values. Okay? Because if I have a negative value, now I have an imaginary number, right? It's not real. It's the I, remember the I thing?
Yeah.
Okay. So, my radical cannot be negative. So, how do I say that? I would have to say the radical 3x plus 12 has to be greater than or equal to 0. So 3x plus 12 has to be greater than or equal to 0. Can I take the square root of 0?
Yeah.
What's the square root of 0? What times what equals 0? 0 times 0 is 0, so we're good. Okay. Can't be negative. Okay. So then, with radicals, I take whatever underneath the radical and I say, okay, that value has to be greater than or equal to 0. Okay. Now I just solve that particular equation. Okay. How do I get rid of the radical? What's the opposite of square root?
Isn't it you put two radicals on a fraction and then you solve from there? Is that something?
Something a little different. What is that?
Square rooted?
Well, it's already being square rooted, so the opposite would be
Square.
squared. Square both sides. So then 3x plus 12 is going to be greater than or equal to 0. By the way, every single time you do it, you're squaring 0. So if you just think about it, whatever's underneath the radical, which is called the radicand, has to be greater than or equal to 0. So then you just solve 3x has to be greater than or equal to negative 12 divided by 3. X has to be greater than or equal to negative. So my domain is simply x has to be greater than or equal to negative 4. There's my domain. And we can absolutely check it. If I put in negative 4, I get negative 12 plus 12 is 0. If I put in negative 5, I get negative 3 values. Doesn't work. So my domain then is simply x is greater than or equal to negative. Now, believe it or not, that's all we're going to talk about in pre-calc. Okay, we're going to talk about those three functions: polynomials, rationals, and radicals. Okay. Absolute value, or just like linear functions. Cubic functions, and those are just polynomials. All right, so let's put a couple of these together. Letter D. It's not what I want to do. Letter D. All right, let's see here. Let's use a different letter. Let's say, oh, I don't know. M of x equals. And on top, I have 3x plus 2. And on bottom, I have the square root of 14 minus 2x.
Teachers, seniors should be back in class in the next 3 minutes. Seniors have been released, they should be in class in the next 3 minutes.
Is that a 14?
Yes, 14 minus 2x.
And you want us to solve?
Well, I want you to find the domain. Now let's think about this for just, we're putting two things together, right? I'm putting rationals and I'm putting radicals, okay? So because it's on the bottom, 14 minus 2x, what's the rule? 14 minus 2x, what do I know about that?
The x can't be negative.
No? Based on rationals, what do I know about the denominator? It can't be what?
0.
It cannot be 0. So I know, number one, I know that the square root of 14 minus 2x cannot be equal to 0. Okay. Based upon the fact it's a radical, what else do I know? That the square root of 14 minus 2x has to be what? Because it's a radical. So go back to letter C, and what did we do with the radical? Yes?
Is it what I just said?
What
Or
did you
is
say?
It can't be negative.
It
Or
can't be negative, so it has to be what?
Positive.
Look at letter C, and what do we set it equal to? Or what do we do?
Square it.
Okay, we'll do that in a second. What symbol am I gonna use?
Greater than or equal to.
Very good. It has to be greater than or equal to 0. Okay. All right, so let's solve each one of these individually. Okay, so I know that if I square both sides, I get 14 minus 2x cannot be equal to 0. So 14 cannot be equal to 2x. So 7 cannot be equal to x. So x cannot be 7. Because if x is 7, that's going to be 0, and the denominator is going to be 0. Okay? 14 minus 14 equals 0. So x cannot be 7. Okay? On this side, let's do the same exact steps. We're going to square both sides. 14 minus 2x greater than or equal to 0. 14 greater than or equal to 2x. Divide both sides by 2. 7 greater than or equal to x. So x, if we switch this around, x has to be less than or equal to 7. Now look at those two statements. Do you see a contradiction in those or something? Do you see an issue? Hey, what's up?
You can't have the equal to part of it.
I can't have the equal to. Because here it says x has to be less than or equal to 7, but here it says, wait a second, x can't be 7. So what's my domain?
All real numbers.
Except 7.
No.
All real numbers.
No. Yes.
Okay.
You're
It would
7.
be 7 negative infinity.
Yes, I would just write it like this. I would just say, okay, x has to be less than 7. I would just write it like that.
No.
But you could write 7 to negative infinity if you wanted to. If you want to do interval notation. Actually, it'd be negative infinity to 7. If you want to do interval notation, that's fine. But you just have to realize that, wait a second, this limitation here carries to this one. And you have to go with the most restrictive choice. Okay, so x has to be less than 7. So the only values I can put in here has to be less than 7. I can put in 1. I can put in negative 5. I can put in negative 13.6. Can't put in 7. Can't put in 8. Nothing above that. Okay. All right, so polynomials, what's the domain?
All real numbers.
All real numbers, always. Okay. Rationals, what's the domain? What's the issue? What do you do?
Can't be 0.
What cannot be 0?
No. The x.
No? Somebody else. What cannot be 0 with rationals?
The domain.
What part of the function cannot be 0? With the rational function. Go back to part B. What did I set? Can't be equal to 0. What? Denominator. Denominator cannot be 0. That goes back to it. X can be 0. Okay, let's go back to this particular equation. Okay. I mean, what if x is 0? Then that's going to be 0 minus 3. That's perfectly fine. It's negative 3. X can be 0. The denominator, the whole thing, cannot be 0. Okay? So polynomials, domain all reals. Rationals, you take the denominator, cannot, just the denominator cannot be 0. What about radicals? What do I do with the radical? It has to be what?
Greater than
Or
or equal to 0.
equal to 0. Very good. You simply take the radical form of the equation and you go, it has to be greater than or equal to 0. Solve for your domain. Okay? That's the 3 restrictions, the 3 we're going to look at. Okay? I want you to try a couple on your own. We're going to give you a few minutes. In your notes, if you'd put these in there. Need to add. Try these. Now, The point is on this one is, I've gone over this, we've talked about it. Now you try these on your own, go back and review your notes, go back and look at them. I'm actually gonna do them in pretty much the exact same order we did in class. Okay, so take a look at each one, walk through A, B, and C, and make sure you get the right answers. So, letter A. F of x equals x squared plus 3x. B. Let's go with g of x equals x minus 4 over x squared plus 7x plus 12. And part C, h of x is going to be equal to radical 9x plus 7. Okay? Find the domain of each one of those. Give it a few minutes to try that. How was your meeting?
Long,
I'm sorry?
very long.
Could you put your phone back on the lock on the camera?
Yeah.
Thank you so much. I really do appreciate that. I don't like to fight about stupid things. So what was the meeting about?
It was just about our overall senior year and what we need to walk the stage, basically.
Oh, yeah. So be here 90% of the time.
Yeah. You know, go get our credits, you know, start applying for scholarships, you know,
Lovely.
stuff like that.
Cool.
I did forget to go see about a computer. It was so long, I forgot.
You have 2 days before you're back here, so I'll just get it done. I did have a question for you, but I forgot what it was. I'll come back. Yes, Logan, you have a question?
I forgot what I was about to say, sorry.
Okay. Very good on number 1. That's done, by the way. Number 1's correct.
Oh, is,